this one up here. All right, well, let's dive in. Good morning to you. So, okay, so notice those two equations are equal level. We've been going for like 10 minutes. No, I'm just kidding. Those are like equal level, right? As far as they're like terms, right? X squared with x squared, xy with xy. Everything's all same old, isn't it? So, that means one of them's not any easier than the other. Because normally we look for the easier one, and we start with the easier one, don't we? When one of them's easier than the other one, we start with the easy one. But these are equal level, so it doesn't matter which one you start with. Okay, so how should we go about it? What should we solve for here?
The bottom of 2x.
Doesn't matter. It doesn't matter. I'm just going to work with the top one. You can do the bottom one. It doesn't matter at all.
Cancel the 6xy. I want to.
Oh, by doing like term, by doing the addition method? Yeah, that'd be fine. You can do the addition method. I'm going to do the plug-in thing, but yeah, that way it would work fine too. Now, it would not be a good idea to solve for x. So I'm going to solve for x squared, but not for x. Does everybody see that? Yeah. Right? That'd be a pain. If you solve for x, it'd be a pain. So it'd be easier to solve for x squared. Does everybody see that? And plug into the other equations x squared. So I'm going to solve for this x squared. How do I do it? Grab this 6xy, jump it to the other side. Then I have x squared is 8 minus 6xy. That good there? And then I'm going to plug that in to the bottom one. So let me grab this second equation. 2x squared minus xy is 3. Grab all this and plug it in right there for x squared. Is everybody good with that? Making sense what I'm doing? Yeah. So I'm going to replace the whole x squared is 8 minus 6xy. So this becomes 2. And then what is x squared? 8 minus 6xy minus xy is 3. Is that good to there? We doing okay? So I just replaced x squared with 8 minus 6xy. And then we can multiply and distribute here. We'll get 16 minus 12xy minus xy is 3. Good so far? Y'all tracking with me? So we always take one equation and plug it into the other, don't we? Now, what do you do with minus 12xy and minus xy?
There are common terms.
Yeah, so minus 12 of these xy's and minus 1 more of these xy's, minus 13 of these xy terms. Good to there. And now let's finish solving. So subtract 16. Like that. So minus 13xy is minus 13. That's very nice.
Xy equals 1.
Yeah, bring it over here. Minus 13xy is minus 13. Divide by minus 13. Xy is 1. Positive 1. Xy is positive 1. Okay, now, I don't have x or y individually yet, but I'm real close now. Now that I have xy is 1, I can plug that in to either of the first two equations and finish solving.
I have a question.
Yeah, Barbara.
So you subtract negative 16 from both sides?
Uh-huh.
And then wouldn't that be negative? Oh, yeah. Never mind.
It's all good?
Never mind.
Other questions? Good. Okay, so we'll go to fresh screen. I'm going to use x, y as 1. Now that I've got that far, I can use that. So everybody see what we're doing. I'm taking the first equation, plug it into the second. I solve for x squared in the first, plug into the second. Pretty much what we're always doing on these is plugging one equation into the other, whatever's easiest, most convenient. And if one of them is easier than the other, I start with the easier one. These were kind of equally easy, hard, however you want to say it. All right, so, and then we'll, what number is this? Number 7. So keep going here on number 7, and we got xy is 1. Xy is 1, and I'm going to plug into, it doesn't matter, first equation, second equation, whatever, it doesn't matter at all. So x squared, what is it, plus 6xy equals 8. Plug in xy is 1, so right there, xy will be replaced with what I now know xy equals. It equals 1, huh? So we'll get x squared plus 6 times 1. So x squared plus 6 is 8, subtract 6. X squared is 2. Root it up and down the ladder, right? When you put a roof on the house, up and down the ladder. X is plus or minus root 2. So we got x. We still need to get y. So we're going to have to plug x in to get y. Good to there so far? When do I need to separate those? Like in other words, do I need to do like x plus root 2 separately and x minus root 2? Remember, sometimes we do, sometimes we don't. I don't know if you remember, like, yesterday, I think it was, yeah, yesterday, one time I plugged like both of them in at the same time, plus and minus, and one time, and all the other times I separated them. How do you know when you need to like separate the plus from the minus, or when you can just say, hey, it's all the same?
If it becomes negative at the end, right? Because it has to be positive.
Well, it has to do with what we're plugging into. So remember, I'm going to plug into these, like first equation, second equation, doesn't matter, they're equal, so I'll just grab the first one. X squared plus 6xy equals 8. So think with me for a second. If I'm going to, let me give a little more room here. If I'm going to plug into x squared plus 6xy of 8, if I'm going to plug root 2 in, positive root 2 in for x there and there, and then over here, I'm thinking about plugging in the negative root 2, and I'm wondering, does that matter? Does that make a difference when I plug in negative root 2 there and there? Is that different than positive root 2? Yeah, because I have a regular x, not just an x squared. So when it doesn't matter is when all you're plugging into is squared. Then who cares, plus or minus? Either way, squared's the same thing, huh? But if you also have a regular x or y or whatever you're plugging into, then you got to do the separate positive and negative because it'll be different, won't it? Does that make sense? So most of the time you got to separate them. We did one of the ones yesterday where all they had was x squared, so I said, I'm not going to separate. It's all the same thing if it's only x squared. Remember that one? All right. Just want to make sure that's making sense for you. All right, let's keep going. So then we got root 2 squared plus 6 root 2y is 8, huh? Let's plug that in for x. And then root 2 squared is 2 plus 6 root 2y is 8. Subtract 2 from both. It's gone. 6 root 2y is 6. Good so far. Divide by 6 root 2. Boom, boom. Y equals. And what is 6 over 6 root 2? 1 over root 2. Good, like that. And we can't leave a root in the bottom. So multiply top and bottom by root 2. And we get what? Root 2 over plane 2. So x root 2 goes with y root 2 over plane 2. Huh? That's one answer. I'll start listing the answers over here. So one of the answers is root 2 for x and root 2 over 2 for y, comma. And now I need to get the other answer over here in the purple. Get the other one. Good so far? And then here we go. Negative root 2 squared plus 6 negative root 2y is 8. So that's 2 minus 6 root 2y is 8. Good to there so far? Just plugged in negative root 2. Then solve for y. Subtract 2 from both. Negative 6 root 2y is 6. Divide by negative 6 root 2. It's just going to be the same thing, negative, huh? So it's negative 1 over root 2, multiply top and bottom by root 2. And it's negative root 2 over plane 2, isn't it? So here we go. The other answer then is x is negative root 2, y is negative root 2 over plane 2. There's our two answers. Is that okay? Yeah, Luis.
Can we use matrices to solve?
Not for nonlinear. It's a good question. So the difference in this section, what's different in this section is there's x squareds and y squareds, not just x to the first power, y to the first power. So Luis's question is good. If you go back to here, see how the original, it's not just x and y to the first power. You can only use the matrices. That was only for solving linear. Why was that only for solving linear? Well, I mean, good question. You could do it with this one because they're like, so what I should really say is yes, you could do this one, but you would only get, you could do this one because it's like terms. So here, let me show you. Yeah, it's a good question. I won't use up too much time. I get too excited about these guys. It's a good question. Yeah, you could do this. Because this is x squared, and this is xy. You could do some matrix stuff if you wanted, because they are like terms. Now, they weren't all like terms, right? If you look back to the other ones we did yesterday, there were sometimes, you'd have like 6x squared plus 2y here, and you'd have 3x plus 5y is 7, is 8, or whatever. And see, this and this are not like terms. If they're not like terms, no way at all. Because the matrix thing that we do assumes that you put the coefficients, right, the 1, 6, 2, -1, right, -1, here, and what here? Well, you have to have just two things. In our case, it's x squared xy. X squared xy equals, and what would be the right side? 8, 3. So you see the deal? With the matrix thing, you have to only have two kinds. See, this would never work. I have x squared, y, and regular x and y. Well, I can't just do two things. I have three different things. That's not going to work. So unless they're like terms, the whole matrix setup won't even fly. Now, if they are like terms, x squared with x squared and xy with xy, then you can do it. But if you did the matrix, somebody have a matrix thing? So I could just take this, what is it, 1, 6, 2 minus 1, inverse, times 8, 3. Remember what you do? It's the inverse of this one times the one on the right. Remember that whole thing? So I could do that real quick, and what would I get? I think I can tell you the answer. It would be... what was xy? Xy was 1. Yeah, it would be 1. The calculator would tell you 1, and what is x squared? I don't know. 2? I think it would tell you 2, 1. Anybody do it? I think it's 2, 1. 2 plus 6 is 8, yeah. 4 minus, yeah, it is. It'd be 2, 1. Now, what does that mean, though? That's the answer for x squared xy. Because that's what I put in the matrix. So x squared is 2, not x. So then you'd have to still go from there and say, okay, so x is plus or minus root 2. You'd still have the more work to do by hand. Does that make sense? See the problem? Yeah. So good question. So you kind of half do it if they were like terms. Can't do it at all if they're not like terms.
If that's on a test, that would be done fully by hand, right?
Yeah, these kind will be on the by hand part. That's right. That's right. Yeah. 9 and 10 are on your graphing calculator. So are you guys comfortable with how you do it in your graphing calculator? You just let y1 be the first thing, x to the power of 1/5, and let y2 be the second thing, e to the power of -2x. And then just graph it. So it's on the graphing calculator. Step 1, you graph. Step 2, you do the intersect thing. You know where you do intersect and enter. Here's the answers I got. 0.17 for x, 0.71 for y, rounded to two places. You want to see if you can get that real quick? So those should be the two answers on the x and the y. If you have any trouble with that, grab me after class. 10 seconds probably, maybe 20 seconds. I can help you with your calculator to get that going. If you have any trouble. I graphed it on the normal window, -10, +10, -10, +10, and it worked out fine. And for the intersect, I just hit enter. Usually with the intersect, you can just go enter, and it just pops out the answer. It worked fine for me on that one. Every now and then, you have to be more careful with the intersect and kind of do the up arrow, down arrow to jump between the curves. But usually, the calculator just knows. And you just go enter, and it just pops it out. All right. I'll move on. Number 10 is same thing, a little bit extra complexity. So there it is, number 10. X squared plus y cubed equals 1. So what do we do? How are we going to do this one on our graphing calculator? Got to solve for y, huh? You can't. You have, when you put in your graph calculator, you got it's y1, y2, so you got to solve for y, don't you? So jump this over. So y cubed is 1 minus x squared. How do we finish solving that for y right there?
Third root.
Third root it. Yeah, good. Third root it. So I'll go third root, and that gets you y alone. Third root of 1 minus x squared. Now, how do you put that into your? How do you put third root into your graphing calculator? Do you know how to do that?
1 divided 3.
It's 1/3 power, huh? So everybody, yeah, good. Sounds like you do know. 1/3 power. That'll be really important when you go into if you go into calculus next semester, is to know that a third root is a 1/3 power. It makes the derivative easier. Something you do a lot in calculus. So third root is a 1/3 power. We all comfortable with that? That'll make life a lot easier in calculus. So put that in as y1. So y1 then would be 1 minus x squared to the power of 1. And you got to put the 1/3 in parentheses. Like that. Why? Because if you just go up 1 divided by 3, it'll only do the first power and then divide the whole thing by a big 3. By a big 3 like that. It won't know that you mean the whole 1/3's in the power. It'll just think the 1's in the power to divide the whole answer by 3. That's what it'll think of this. It won't understand that you mean the whole 1/3's in the power. So in other words, using a calculator, whenever more than one thing is in a zone, what do I mean by zone? Numerator, denominator, or power. A zone. Whenever more than one item needs to be put together in a zone, numerator zone, denominator zone, or power zone, you must parenthesize it, telling the calculator this whole 1/3 is in the zone together, the power zone together on that. So do that. So that would be y1, y2, right here. So x cubed y equals 9 divided by x cubed. So y is 9 over x cubed. Put that in. That would be y2. y2 is 9 divided by x to the third. So put in y1, y2, graph it, intersect. I don't remember what the answers are, but you can do it. So in fact, I'll do it real quick if you want. Yeah, in fact, I still got it in my calculator.
That's
So
such a word.
graph. Calculator, go to intersect, and I'm getting negative 1.88, comma, negative 1.36. Right? Negative 1.36, yeah. So did you get that answer? You might need, now this one at first made me, I tried just hitting enter, and it wouldn't do it, bless you. I tried to say enter, and it wouldn't do it. I had to do the up arrow, down arrow. Do you know what I mean by that? Do you know what I mean? To make it jump between curves? I'll show real quick. We've got a lot of time for this, but maybe a little. So, thought I did Elmo. I didn't. Here. So there's the graph I got. I'm just on the normal window, negative 10, positive 10, negative 10, positive 10. And then when I hit second calc, I go down to intersect. And then see, it asks me first curve, second curve. It's going to ask me first curve, second curve. So what I do is I have to hit the up arrow, down arrow buttons right here. These up and down arrow to make it jump. So it's saying first, it's saying you can move right. Do you know how this works? If you move right and left, you'll move along the curve. The first curve is that upside down U in the middle. The second curve is the two branches together, is the second curve, the Y2. So I'm moving right and left. You don't have to move right and left, but I'm just verifying, hey, this is the first curve. It's saying, am I on the first curve? You just hit enter, yes. You're saying, yeah, you are. Okay, now am I on the second curve now? Well, see where my cursor is? See it's up there? Is that the second curve? Yeah, that is. The two branches together are the second curve. And you might say, yeah, but it doesn't hit over here. You're right. Sometimes that's a problem. It'll be okay this time. It'll work. Now, if it ever causes a problem, the way you can jump to the other curve, if it somehow ends up on the wrong curve, is you can push the up arrow, down arrow. So right and left, just moves you along the curve. Up and down jumps to the other curve. See that I pushed up? See I'm on the other curve now? Or I push down, doesn't matter, up or down, either one. Back and forth, up and down. I'm just pushing down every time. It's jumping back and forth between the two curves. It will not jump to this one unless, how do you get to that one? I got to be on the top one and move far left. Whoop, see? There, see? I showed up over here. Because those two branches go together, I just had to keep going left. Anyway, you don't need to go over there, it doesn't matter. Just hit enter, enter. And there it is. Good? Having trouble with that? Come see me, be glad to help. All right, I'm going to end this.